When you shine a white light through a prism, you find out that it contains a rainbow of colors. This is called dispersion, and it happens because light of different wavelengths or colors refracts or bends by different amounts inside the prism. The rainbow could be described as a spectrum, and if the spectrum goes all the way from red to violet with no gaps, then it is a continuous spectrum. A beam of perfectly white light, like you would get under certain laboratory conditions, contains this kind of spectrum. But as we'll find out, most light, even the light from the sun, does not contain a continuous spectrum. White light might be a continuous spectrum, but it's only part of the electromagnetic spectrum. There are more wavelengths than we can see with our human eyes. A wider continuous spectrum would include radio waves, microwaves, and infrared, ultraviolet, X-rays, and gamma rays. As far as we know, no object in the universe sends out waves across the whole of the electromagnetic spectrum, so finding a continuous spectrum spanning the whole of the electromagnetic spectrum would be impossible. The following diagram shows the full electromagnetic spectrum and everything it contains. The energy of waves increases from left to right across the electromagnetic spectrum. The sun is extremely bright and gives off an immense amount of energy, but it turns out that it isn't even close to giving off a truly continuous spectrum. Even though we do see a rainbow when light is refracted after it rains, when we look at the sun's light and analyze it in detail, we find that there are gaps where we see nothing at all. When we take the sun's light and put it through a spectrometer, a device that separates light by wavelength, the sun's spectrum looks something like this. The gaps in the sun's spectrum are called absorption lines, and they give us valuable information about the sun. Here's how it works. The sun contains elements like hydrogen and helium. When the sunlight, including ultraviolet and infrared that we can't see, shines through these elements, they absorb the energy. But they only absorb electromagnetic waves that are just the right color to match the energy they need. This gives us those gaps in the sun's spectrum. Each element in the universe has a different combination of absorption lines, so we can use the sun's absorption spectrum to figure out what elements are present in the sun. This is how we know what the sun's made of. An emission spectrum is the opposite of an absorption spectrum. Instead of getting a mostly continuous spectrum with a few particular colors missing, in an emission spectrum, we only get those few particular colors. These are called emission lines. Instead of shining light through a gas, as we do to create an absorption spectrum, to make an emission spectrum, we heat the gas up. This causes the atoms to absorb the energy. Before long, that energy is re-released as light, and the color of the light that is emitted is different for every element. So, we can look at the emission spectrum of any given gas to figure out what elements are in the gas we're heating. Let's review. There are three main kinds of spectra that we have explored: continuous spectra, absorption spectra, and emission spectra. A continuous spectrum contains many different colors or wavelengths with no gaps. Perfectly white light shined through a prism causes dispersion of the light, and we see a rainbow. This is a continuous spectrum. However, visible light is only one part of the electromagnetic spectrum, which also contains infrared, microwaves, and radio waves on the red side, and ultraviolet rays, X-rays, and gamma rays on the blue side. Even though we see a rainbow in the sky when the sun shines after it rains, this is not actually a continuous spectrum. Most light in the universe, including light from the sun, is not a continuous spectrum, but is instead either an absorption spectrum or an emission spectrum that we can see through a spectrometer. When light is shined through a gas, like in the sun, the elements there absorb some of the light, creating an absorption spectrum with absorption lines. Conversely, when a gas is heated, the atoms in the gas absorb the energy and emit light, and an emission spectrum results. The lines in the emission spectrum are called emission lines. Looking at absorption and emission spectra can tell you what elements are present in stars like the sun and other gases.